Hello everyone, this is Levent Gurdemir, UTA Planetarium Director, and welcome to UTA Planetarium's another live Star Talk. Today we are going to do a small tour about night sky. But before we start, please drop your questions, if you have any, to the comment section, and we'll get that answered during the talk. And tonight's sky, after sunset, in the west direction, if you look at the sky, I know it is cloudy right now, but hopefully the clouds are going to go away and it will likely by sunset. Just look at the west direction and say hello to a very tiny crescent moon. It is just coming out of from the new moon phase and showing a little tiny nice crescent. And even if you have any binocular or telescope, you can just take a look and see a nice features on the moon. And here I would like to start as thanking to Planetarium staff. They are great. Jim Bader, program coordinator, and our moderators, Jennifer Jones and Huzaira Sohail, is going to take comments and moderate the questions. So, right after sunsets in the west direction, where the moon is, you will actually see, just on the right side, you will see two bright stars. Those are the bright stars of constellation Gemini, Pollux and Castor. Gemini is a Latin word for twins. You know this constellation actually from from your daily horoscope. But let me tell you, this is not a horoscope talk. We are not going to talk about horoscope, but we are going to talk about the constellation and the stars itself. So we use zodiac actually as a coordinate system of the solar system objects. And here's a good example. If you ask where the moon is tonight, it's around the constellation Gemini. Pollux and Castor are the bright stars of twins, and the Pollux is a red giant star that is 33 light years away. What is a light year? 1 light year is the distance of the light that travels in 1 year. Well, if I said Pollux is 198 trillion miles away, that would not make a lot of sense. But when I say 33 light years away, that light travels 33 years to reach Earth. That means actually we are looking at Pollux's appearance from 33 years ago. There is at least one massive planet orbiting Pollux. How about Castor? Castor is 51 light years away. Castor doesn't have any confirmed planets, but has 2 companion stars orbiting around it. Are there more constellations in the zodiac? Of course, let's find them out, but we need to do some star hopping first to do so. Let's turn our views to the north direction. So how do we find north direction if we don't have giant letters like we have on the screen? It's very easy. Let's actually look slightly above, and you cannot miss this 7 bright stars that forms a great dipper in the sky. It is called Big Dipper. If you remember from the past videos, we used cap stars of Big Dipper to find the North Star Polaris. Let's draw our line to find the North Star. Well, this star points us the north direction. But we are not going to use the North Star today. We'll go back to the Big Dipper, and we will use the handle part. The handle part is kind of in the shape of arc. We will extend the line from that arc, and it will end up in a bright star called Arcturus. So we just arc to Arcturus. Arcturus is also a bright star, and we'll go and continue on the same path to find another star. On the same path, it will lead up to Spica. So we just sped up to Spica. Spica is the bright constellation, the bright star of constellation Virgo, another zodiac constellation. And right below Virgo, we see another constellation called Libra. It is very easy to identify Libra, mainly like there are 4 stars in Libra, but the top 2 stars are going to be like equally bright and the identifiable stars. So why it is Libra? In fact, Libra has 2 bright stars. The main stars are named Zubin al-Shemali and Zubin al-Jamani. Those are Arabic names. Well, Zubin al-Shemali means northern cloud. Zubin al-Janabi is southern cloud. In fact, to the Egyptian astronomers in the past, Libra was a scorpion, has 2 clouds. But then in the Greek mythology, it was named as Libra because back in time, we are talking about 5,000 years ago, the equator line of the sky, which divides the sky to the northern hemisphere and southern hemisphere, that line was crossing through the Libra constellation, leaving Zubin al-Shemali on the north side and Zubin al-Jamani on the south side. So that constellation was actually kind of looked like in balance on the equator line. So that's the word coming from Libra, the scale. Libra is also famous units for us. It's actually the representation of pound we use every day at the shopping stores. And also the currency in the UK. Let's go back to the Virgo constellation. Virgo is a little interesting, and the May is the best time to look at Virgo constellation. In Virgo, there's a region that has a big cluster of galaxies. We call this Virgo cluster, and Virgo cluster includes roughly about 2,000 galaxies in them. So the distance of this galaxy, the cluster is 65 million years. Well, that means the light traveled 65 million years. But also, if someone is watching Earth from that distance, that means they are right now watching or about to watch the big meteor impact events that occurred on Earth and what we think ended the dinosaurs. So from that distance, you can actually see that it's happening now. Well, hopefully someone is watching us from there. One galaxy among these the cluster of galaxies is very interesting. It is called M87. Its catalog number, Messier catalog 87. It's a great, stunning elliptical galaxy, and there is a central black hole is located on that galaxy. Hubble pictured this galaxy. Hubble has an amazing picture showing like a gassy tail coming from the galaxy. That's very hot plasma jets produced by the black hole and pushed away from the galaxy. And the speed of the jet stream is nearly speed of light, which is an amazing picture. There is also a radio picture of the same galaxy taken by the great radio observatories, radio telescopes. And that picture also reveals the small jets coming perpendicular above and below the great central black hole. Well, in the visible light one, you can see, if you'd like to see the streams, let's go back to that again. The jet streams, they are very hot plasma and subatomic particles, again produced by the black hole and ejected out of the galaxy. And they are, like, jets are amazingly fast, nearly the speed of light. So Hubble takes and continues to take amazing pictures for us, and those telescopes are very important to understand the happenings in the universe. And black holes are particularly interesting. So there's a lot of still frontier research going on about black holes, and black holes are challenging us with our understanding of space and time. Time slows down around black holes and stops on the surface. So the black holes also bend the space around them in curves, and the light takes those curves when passing near black holes. If you would like to hear more about black holes, that should be in another video, another week live stream, because that's a broad topic. If we go dive into that, I don't think we will be able to get out of that within 1 hour. All right, let's take some questions. Well, our first question is how many stars exist in the universe, and how many constellations? Let me answer the easier one. How many constellations? Well, constellations are determined by the International Astronomical Union, and it was way back in time they decided that we have 88 official constellations. Everybody is allowed to imagine their own constellation, but officially the number of constellations is 88. However, the number of stars in the universe, I don't think anybody's estimation is a good estimation. Let's imagine just our galaxy itself has 200 billion stars. Well, that's a big number, but how big? To imagine that, we need to think about how many grain of sands exist on a beach. That number is about 200 billion. Number of grain of sands on a beach. Well, if just our galaxy alone has 200 billion, and just in the Virgo cluster, just one thing we see in the sky, one direction, we have about 2,000 galaxies, and there are certainly more we spotted around the universe. We estimate the number of galaxies exceeding billion. Do you know math? Multiply the two numbers, you can at least get an idea the magnitude. It's not going to fit in your pocket or desktop calculator. You need computers to do that type of multiplication. But the number of stars are extremely great numbers that you put a lot of zeros on the next side. The next question is the Big Dipper is always in the north? The Big Dipper itself is not associated with the Polaris, the North Star. But yes, it is always in the north area, because what happens is as Earth rotates, the Big Dipper rotates around the Polaris, the North Star, in the counterclockwise direction. So it never goes far east or to the west side. So approximately we always find the Big Dipper approximately in the northern area. Sometimes it is above the North Star, and sometimes it is below the North Star. whose location never changes in the sky is the North Star. Now, there is nothing special about that star, but where it is sitting is important. Earth rotates around its axis, and that axis points where the North Star is. That's why North Star appears to be in the center of the daily motion. Great questions. What happens inside of a black hole? A lot happens. Well, we can even our physics, the physics around and nearby black hole is very challenging. When we go to near a black hole, the, the, the space curvature changes, the time slows down, and as we approach to the surface of a black hole that we call event horizon, the time stops. The space-time gets extremely weird, and what's inside is there is no information from the inside of a black hole. No light can escape from a black hole. Um, if anything goes in a black hole, it doesn't come out because an object to be able to escape from inside of a black hole, it needs to travel much faster than speed of light, and that kind of speed, as we know of, don't exist in the universe. However, Einstein's predictions were because they are significantly bending the space curvature. Maybe they are connecting with, by bending the space curvature, they are connecting with other parts of the universe. Or maybe they are touching to another universe. So that means if we enter into a black hole, we may find ourselves in a different universe, which the physics is different, the atoms are different, the forces acting on the atoms are different. It may be a completely different universe. Or if the wormholes exist, we may find ourselves in different part of universe, which enables traveling faster than speed of light. Well, it seems like there's a lot of interest to the black holes. We really need to do another black hole talk with you guys. Uh, Let me get the question again. What is the name of the constellation in another constellation? I'm not aware of the any constellation in constellation, but the constellations may have different names. And again, the constellations, they have about 5,000 years long history, and using by the Egyptian astronomers, Arabic astronomers, and the Greek astronomers. And in different cultures, they represented different things. So that's why we have different names. For example, we have official or astronomical constellation names. Big Dipper, for example, the official name is Ursa Major. We designated with UMA. There is an asterism name, uh, Big Bear is the asterism, and there's also some constellations have common or public names, like Big Dipper is a common or public name of the Big Bear or Ursa Major constellation. What's the best place to view stars? Uh, Darker places are better for observing the stars because if there are lights around, lights leaking from cities, they are providing a lot of background lights in the sky. So that background light flushes away the dim stars. If you would like to see the stars, the dimmer stars, or more beautiful sky, the darker skies are more preferable. And where are they is a challenging question because the big cities leak a lot of light, and the light is actually reaching a couple hundred miles away from cities. So rural areas, countries are much better for observing conditions. Some other conditions are also humidity is also a factor. Um, Local star parties, usually the amateur astronomers for local star parties, they are selecting great locations, best locations. Observatories can be also great locations. For example, if you're in Texas, McDonald Observatory, um, it's about 9 hours drive from Dallas Fort Worth, but it's worth it. They are currently closed, as far as I know. But when, when they open, it can be a great locations. If you are looking for nearby Glen Rose area, featuring Dinosaur Valley State Park, is also a great location. Um, uh, so in this area, that's it. If you are looking for some places in Arizona, there are also great places too. What is the closest star with a planet? As far as I recall, there is a confirmed planet around Alpha Centauri. I need to look it up, but that star system is roughly about 4 light years away. So we consider it very close, and that star system has a planet around it. But when we look at the confirmed planets, we found, thanks to the Kepler mission, we found several thousand confirmed planets. But still, they are in what we call local area. We are looking at the close neighborhood for planets because it is extremely difficult to observe and confirm the planet system. If the planets are far away or orbiting around far away stars, it is extremely difficult to notice them because of all the technical difficulties and need for larger telescopes. Well, I think we have one more question left. I would like to thank everyone for the great questions. Please send your questions through comments after this video even. We'll try to get them answered. The next question is a great question. The final question is a Pluto question. Why we are keeping, including and dropping the planet status of Pluto? This is perhaps the could be topic for another video. But first of all, we love Pluto. That's period. We have absolutely great love with Pluto. However, as the access to better telescopes, we started finding more and more objects in the solar system. First, we were aware of the planets. And then at the beginning of the 1900s, around 1920, we added this ninth planet. The first planet discovered by an American is Pluto. The Pluto did not fit to the other planets because Pluto was different in appearance and size. Pluto is icy planet, and Pluto is a tiny planet. But on the outer part of the solar system, we find large and large planets, right? We find Jupiter, Saturn, Uranus, and Neptune. But what we discovered later, beyond Pluto, there were another millions of objects. They looked like Pluto. So we cannot say they are planets. They are, because it looked like we just discovered another asteroid belt, the secondary asteroid belt outside or on the outer side of the solar system. So rather than calling it planet, Pluto fits to those asteroids better due to its shape and size. So, and this is not called asteroid belt, by the way. We call this secondary asteroid belt Kuiper belt. So it looked like the Pluto fit well to the fit well as a Kuiper belt object. So that's why we decided to reclassify Pluto as a Kuiper belt object or dwarf planets rather than the planet. But it doesn't matter. It is just a name we give. After all, Pluto is an orbiting solar system object. It is orbiting the sun, whether it's called planet or not. And tomorrow we may change our mind. We may go back and give planet status to Pluto anytime. All right. Great. If you like our streams and videos, please drop your comments and feedback, and we will go ahead and respond to that as quick as we can. Thanks to the great Planetarium staff again. A lot of people are working tirelessly to make these happen. Thanks to Jim Bader, Jennifer Jones, Huzaira, Sohail. And if you like us, tell us. We'll be back next week, Tuesday, the same time, and our weekly night sky videos will continue. And keep watching us and keep following us. Thanks, everyone. See you next week.